Hello everyone. We are the Achievers group with two members. Amosha will present slide presentation and I am Sakura. I will be walking you through the project where I use Python for predictive analysis on employee attrition. We'll look at how the logistic regression model was applied to predict whether an employee will leave the company or stay. Let's dive into the key steps: data processing, model training, evaluation, and visualization. For this demonstration, I use Python for coding and executing the analysis. To write the Python code, we use the Google Colab. We have to open new worksheet. Then we have to upload our dataset. Here is our dataset. First, I will show you our dataset. Here is our dataset. This dataset contains details about employee demographics, job satisfaction, and whether they left the company. The goal is to predict this attrition column. Let's begin the coding, performing some initial exploration. Here is the code for that. We need to replace our dataset name in here. Otherwise, coding is not run well. Here, I use pandas to load the dataset and check its structure. Next, we need to clean and pre-process the dataset for analysis. The code for that. Let's move to the dataset again. You can see I highlighted few columns, which is employee count and over 18 column. Finally, standard hours column. I dropped these columns as they didn't contribute meaningful information to the prediction. And categorical variables like gender and business travel, which I highlighted by green, were converted into the numerical values using label encoding. Let's move our Google Colab worksheet again. Next, I scale the data and split it into training and test sets. Here is the code for that. Why we use scaling? The numerical features for scaling use stand scaler to ensure all features are on the same scale, which is important for logistic regression. Train, test, split. The data was split into 80% training and 20% testing to evaluate model performance on unseen data. Now, let's move to training the logistic regression model with class weighting to handle class imbalance. We use this code for that. Since the dataset is imbalanced, more employees stayed than left, I use class weight balance to give more importance to minority class. After training, I evaluated the model using key metrics such as accuracy, precision, recall, F1 score, and ROC AUC score. This is the code for that. In here, classification report. It provides precision, recall, and F1 score for both classes, employees who stayed and those who left. And confusion metrics. It shows the number of true positives, false positives, true negatives, and false negatives. The ROC AUC score. It gives a summary of how well the model distinguishes between two classes. To make the results more intuitive, I created visualization of the confusion matrix and the ROC curve. Here is the code for that. Moving into our data set again. The confusion matrix heat map visually shows how many predictions were correct versus incorrect according to this. Again, move to the Google Colab worksheet. We can run now. Dataset. Here are the details. Final results of our coding. The ROC curve help us understand the here is the ROC curve. ROC score, and this is the ROC curve. It helps us understand the trade-off between true positive rate and false positive rate with a score of 0.76, showing the model's moderate performance. In summary, this project demonstrated how Python can be used to predict employee attrition using logistic regression. While the model performed reasonably well with an accuracy of 72% and an ROC-LUC score of 0.76, there is room for improvement. Potential next step could include using more advanced models like random forest or addressing task imbalance using SMOTE. Thank you for watching.